We're going to talk about radians and what this should actually look like on a coordinate plane. Now, I showed you in degrees before, but it won't look like that when you actually graph it. So that was actually a simplified version of what the sine curve should look like. So what I'm doing is I change it into radians, which we've already talked about, and I'm going to go through and put in the values, the decimal values, and then we're going to look at it again. We have the radians, and then we have the decimal values that correspond to each of these 90-degree increments. So what actually goes on the x-axis, as you know, are values, are just the way we see a coordinate grid. This is the same way now. We looked at it with degrees, we're going to look at it with decimals, and we're beginning to understand why 1.6 represents 90. Because that's the circumference of the circle. That's the arc that corresponds with 90. Now, what we know what 0 is. We know 0 is 0, 90 is 1. Okay, 0. So 1.6 is going to be 1. At 180, it's going to be 0 again. At 270, it's going to be negative 1. And at 6.28, it's going to be 0 again. It's going to do that in both directions. Now I could put in the reference angles, and we do it the same way. Here are our values. The radians, pi over 6 corresponds with 30 degrees. That's the length of the arc of your angle. That's 30 degrees. And if I change it to decimals, it's 0.52, and so on. Now, the moment we've been waiting for, I put it in desmos. Y is equal to the sine of x, the function I put in here. And let's look back at our values. And let's just start out with these values, actually, to make it easier. Okay, so at 90 is 1.6 on the x-axis. At 1.6, is it 1? Remember, it's 1.6-ish. They're all irrational numbers. Okay, here we're at 1.6, and that's where it reaches its peak, which is 1. I'm going to come in a little bit. And yeah, that's 1.6, and that's 1. Now let's come back to here. And our pi is 3.14. We know it's irrational. It goes on forever. But let's see. Let's go back to Desmos. And at 3.14, well, look at that. We're at 0. And they actually give it to us in radians. I didn't realize we could hover over it. But let's come back here. And sure enough, here, let's look at this value now. 270, you get 4.7, and we should be at negative 1 at 4.7. 4.7, look at that, negative 1. And now we're going to go and look at the 360, and we should be back again. And, oh, let's look, 360, 6.28. 6.28, look at that, we're back again, and it's going to keep going in both directions. I'm going to zoom out so you can see. This function goes infinitely in both directions.